In section 16.3, we discuss conservative vector fields and the fundamental theorem of line integrals. Okay, so before we get to the fundamental theorem of line integrals, we first need to introduce conservative vector fields. So if you remember, the gradient of a function, it produces a vector field whose components are the partial of f with respect to x and the partial of f with respect to y. So now we want to turn the situation around and say, starting with some vector field capital F, is it possible to find a function little f such that the vector field is the gradient of little f? So a vector field that can be written as the gradient of some scalar function is called a conservative vector field. And the scalar function little f is called the potential function for the vector field. So conservative vector fields, so a vector field of any dimension can be conservative. However, this section will only focus on two-dimensional vector fields. Okay, so not every vector field is conservative. So we need a condition to be able to check whether or not a given vector field is conservative or not. And the idea is given here, right? So starting with a vector field f whose components are p and q, if you calculate the partial of p with respect to y and also the partial of q with respect to x, and the two things are equal, then this will verify that the vector field is conservative. And the basic idea for this condition is that if in the situation where the vector field is conservative, right, so it should be coming from the gradient of some function, right? So that means that this little f sub x should be equal to p. But now if you take the partial of p with respect to y, this is just taking the mixed partial for little f. And similarly, if the gradient is equal to the vector field, then f sub y is equal to q. And then now if you take the partial of q with respect to x, again, this is the same as the mixed partial of little f. And in the situation where you have continuous first order partial derivatives, then these two mixed partials are equal to each other. And so we get exactly this equation here. Okay, so so now suppose we verified this condition for a vector field, so we know that it's conservative. The next step is to be able to find the potential function for the vector field. So the basic idea here is that if the component p is the partial with respect to x, the partial of f with respect to x, then to recover the potential function, you just need to integrate this with respect to x. And then similarly, if q is the partial of f with respect to y, then to recover f again, you just need to integrate this with respect to y. So that there's a slight typo here, so this should be with respect to y. Okay, so so we calculate these two integrals, and so one thing to be careful about is that even though both of these integrals are equal to the potential function, when we actually do the calculation, there are going to be some differences in the terms. The reason is because the component p and the component q are functions of two variables. However, here we're only integrating with respect to one variable. So what that means is that these calculations are partial integrals. And in the situation where you calculate an indefinite partial integral, typically there's going to be a constant term. And in this situation, the integral here is going to have a constant term that's actually a function of y. And the reason is because when you integrate with respect to x, you're thinking of y as being constant. And similarly, the integral here will have a constant term that's a function of x, because when you integrate with respect to y, you're thinking of x as being constant. Okay, so so basically, when we want to determine a vector field is conservative or not, this is the procedure is outlined here, right? So first, we check this condition, and if they're equal, then it is conservative. If they're not equal, then it's not conservative. And in the situation you do have a conservative vector field, to find the potential function, we calculate these two integrals and compare the terms.